All right, welcome back. I've got a fun one for you today. We're going to be basically making Photoshop. Kinda. All right, so on Canvas, there are some starter files. This is called PictureLab. It is actually written by Barbara Erickson. She is a professor at Georgia Tech, and she wrote this for the College Board. So this is kind of a project, a lab that the College Board is putting out to help us with 2D arrays. So if you click on this, and this is just going to take you to a Google Drive where you can get a hold of these source files. Now, a couple of ways to get a hold of this. You can download this, or you can just right-click the entire folder and tell it to download, which is what I'm going to do. Or you can open it up and basically download these one at a time. Now, hopefully you're noticing we got some pretty interesting photos going on here. The way this lab shipped, it was using like beach pictures and pictures of a swan and a bicycle. That's lame. You get an E for effort, but I instead am using these presidents riding animals. This is by a guy named Jason Huser. His deviant art profile is Sharp Writer, and this is what he's known for, right? He's just making ridiculous pictures of presidents with animals. We're going to use those instead. So I've included those. You can download those. You can download these things individually, which has its advantages because whenever you bulk download the folder or even come in here and highlight everything and download it, Google Drive is going to zip it. Okay, so what I have downloaded here is a compressed zip file. We have to decompress it before we can move it in IntelliJ, right? So if I open this bad boy up, this is a compressed file. Okay, I can't just move it into IntelliJ like it is. In fact, I'm actually going to go ahead and create the project. I'm going to go next, next. I need to switch to my CSA folder. And I'm going to call this one PictureLab. I'm going to make sure the subfolder gets created. And so if I tried to just like drag and drop this onto the SRC, IntelliJ is not even going to let me do it because it's compressed files. I need to decompress, in this case, extract. So I'm going to extract. You could extract directly to this SRC, but what the extract is going to do is actually extract the folder. So we would then have SRC, SRC, which is not exactly what we want. I'm going to go ahead and extract it somewhere. Downloads, desktop, wherever you like, just keep a note of where it's going. So I'm going to do that. I'm going to navigate to my downloads folder. And you see here in the downloads folder, we have the zip file, right? It says zip archive. And then we have the file folder. So this is the compressed. This is what we just extracted. It is decompressed, right? I'm going to open that up. And I'm going to grab all these bad boys. A hint here, Control A in Windows will highlight everything. But I'm going to drag these files onto this SRC. It's going to let me, I promise. I'm having a hard time with my solid state hard drive recently. Hello. Let's try that again. There we go. All right. So we're moving these files, and IntelliJ is just giving you this prompt that's saying, hey, you're about to move these from your downloads folder or wherever you extracted it to this SRC. Do you want to do that? Yeah, I do. Okay, in practice, I would put the image files in a different folder. In fact, I used to do that, but it just becomes difficult for students to know that, okay, the images need to go here and the source code needs to go here. So I just put it all in the SRC, right? We got our images along with our source code. So what we're going to do now is explore a picture. There are several classes here, right? Anything that ends with a JPEG, that's an image. Anything that ends with a GIF, that's an image. But these other things, right, we see C's as icons in IntelliJ. These are Java classes. I want you to double click on Picture Explorer. Right, here is the credits. I did not write this. The College Board technically didn't write it. They got people to write it for them. But there's a lot of code already in existence here. And if you actually scroll all the way to the bottom, you don't have to, but all the way at the bottom is our actual main method. And you see that all we do in our main method is create a picture object, and it reads from this file location, right? So we're going into the SRC and we're getting washington.jpg. And then we're taking that picture object, pics, and doing explore, which is actually going to launch a GUI. I'm going to right click in free space and tell it to run this. Note that picture, that's a class over here. That's a class that they made. It's not like it's something that already exists in Java. Oh, okay. So here is our Washington picture, very historically accurate. But this other stuff, right, we got a little bit of a GUI here. We got some things that we can click. And as it turns out, you can actually click on the picture itself. So I'm clicking around in the picture. And notice we got values changing up top. Right, if I click over here, we get a very much so get an orange. There's a little yellow cursor. I don't know how hard that is to see. But take a look. We see color at location is that orange, and we see RGB values. We've talked about RGB, and we'll talk about RGB again, but ultimately, notice that my row and column is changing. That's because all a picture is a 2D array. It is a 2D array of pixels, right? Just little dots of color. In fact, they've included some zoom functionality. If we zoom all the way to 500%, you can start to see the individual pixels. Right? As I click along in here, or even use the arrows to kind of adjust the cursor position, we can change rows and columns and get the actual pixel color that is there at that location. So this is all an image is. Right? There's lots and lots and lots of pixels. And whenever you just zoom out at like a normal viewing, you can't tell the difference, right? The eye can't tell the difference between pixels because they're tiny and they all just kind of go together. Okay. One thing I would ask is, what is the size of this picture? And what's the dimensions? Okay. That's actually not hard to get. We can just click like way down here at whatever the bottom little pixel is, and we get something like 727 by 1096 is what it's showing. I believe if we were to actually like right click on the file and get like some information about it in Windows, it would tell us there. But that's the size of it, right? There are 727 rows to this 2D array and 1096 columns. Okay. A related question I would ask is, what's the file size? I'm sorry, what? Okay. So we were just talking about pixels, right? And RGB values. Right. If you look at an advertisement for a digital camera, it'll tell you how many megapixels the camera record. What is a megapixel? A digital camera has sensors that record color at millions of points arranged in rows and columns. Each point is a pixel or picture element, right? Pixel, that word is picture element, abbreviated pix. A megapixel is 1 million of those. So a 6.2 megapixel camera can store the color of over 16 million pixels. That's a lot of pixels. Do you really need all of them? If you are sending a small version of your picture to a friend's phone, then just a few megapixels will be plenty. But if you are printing a huge poster from a picture, you want to zoom in on part of the picture, the more pixels will give you more detail. How is the color of a pixel recorded? We tend to represent these things in RGB, right? Red, green, blue. Amounts of red, amounts of green, amounts of blue. Okay. And we know that that ranges from 0 to 255. But why? Why 0 to 255? That's because right? Like each one of these, like the red can be 0 to 255. The green can be 0 to 255. The blue can be 0 to 255. If I come back here and I click on that orange, we see 240 red. We see 144 green. We see 60 blue. And what's so cool about that value is I don't have to move it over. I can do a color picker, right? The Google's got one here. I can punch in those exact numbers, right? 240 red. 144 green, and 60 on the blue. And that is the exact orange that I have here. Right? That's kind of the point that we even have this RGB color model, is that whenever I give you these numbers, you get the exact same color. Okay? But my question is, why 255? Right? Why 0 to 255? It seems like such an arbitrary number. Why not just like 0 to 100? Well, that is because the amount of red is stored in 1 byte. That is 8 bits, right? And the range of a byte is 0 to 255. In that is 256 different numbers, right? 0 itself counts. The smallest number is 0. The largest is 255. So that is 256 different numbers just for the red. The green's also going to get 0 to 255. The blue's going to get 0 to 255, right? So that's 1 byte, 1 byte, 1 byte per pixel. Each pixel is 3 bytes. So whenever I say this thing is, 725? I thought it was, 726 by 1096. That is 726 times 1096. 726 times 1096. Let's try that again. 795,000 pixels are here. That's pixels, though. So in terms of size of the image, I multiply that by 3. In theory, this is how many bytes this takes up, which is like 2.3 megabytes, maybe larger. A lot. That's actually like pretty large. Is that megabytes or? Yeah, it's got to be megabytes, right? Okay. Or sorry, it's like, I don't know. Anyway, it's large. If we stored it in what we call a raw image format. As it turns out, this particular JPEG, it's not in the raw image format. It's actually compressed. What do I mean? Well, we can kind of tell that it's compressed. If I zoom in, right, you see like the little discolorations that we get. Can I like zoom in maybe somewhere else? There was a lot of it going on here with this haze. Right? You get that deep fried effect. I see a lot of it down in here. That's because this image is compressed, right? When it comes to JPEGs, JPEGs have a lot of image compression. Effectively, instead of saving the raw data, right? Instead of saving 2 million pixels, not 795,000 pixels. Instead of creating a 2D array and all of those spaces being unique, the JPEG kind of smooths it out. It looks at a cluster of pixels that are very similar, if not the same, and kind of goes with an average instead. That tends to produce more repetitive data, and we talked about compression last year, where once you have repetitive data, you can just be like, I have 17 of these in a row, as opposed to each one of those 17 being a unique pixel. Okay, I didn't really mean to go off on this tangent about compression, but what I wanted you to know that is, if this was a raw image, it would be this many bytes. It would take up a significant amount of space. Instead, it is compressed, and give me a second, I'll tell you exactly how big it is after compression. Where is Washington? There he is. All right, compressed, it is only 134 kilobytes. All right, this many bytes. Uncompressed, it should be this. Significant size difference there, thanks to the compression. Okay. That's actually a good spot to pause. I know this one was short, but we're just getting started on the PictureLab and exploring pictures. We're going to come back to this. My main goal was to get you set up so that you have the files ready to go. So if you got issues, try to get those resolved so that we can just smooth sail through the next few videos. I'll see you in the next one.